All right, friends and neighbors, welcome back to another networking video. So today we're going to do a little bit on Cisco Packet Tracer applications. That is some of the things that you can do with one of the hosts today. But I think the other value in this particular video is that I'm also going to show you what it takes to actually connect to a real life router, because Cisco Packet Tracer is software and you're not actually connecting things. So I'm going to talk a little bit about what you might actually experience and what you might actually do to connect to a router initially, and then how you might go about building. So without further ado, some applications that you see on the Cisco Packet Tracer node and how we might connect in real life. So first of all, I already have a Cisco Packet Tracer playlist. It's fantastic for getting used to all of the builds that you normally have to deal with, right? If you're dealing with switches, you might be looking at spanning tree topologies. You might be looking at 802.1q, VLANs, and trunks. So it's terrific for that. And the real value, I think, in Packet Tracer is that when you're connecting or using a particular device in Packet Tracer, the interface that you use is exactly what you would use if you were connecting to a real switch or router. It's also fantastic, and I've got examples for doing ACLs and routing protocols and things like that. So pretty terrific tool, and I use it a lot in my classes. It's also free, so that's kind of handy too. But we haven't talked very much about some of the applications. There's one that we use all the time, and that is the command window. But today we're going to use a couple more and talk a little bit about how we might actually compare that to real life. And I say that because when you're dealing with a simulator or an emulator, it's all connections in software, right? You draw a line between two things and it magically connects. But there is, in my experience, a disconnect in our brains between what kind of port that we're actually using, what do we need, and what kind of cable. So I have seen many students connect Ethernet cables to COM ports or serial cables to Ethernet ports. So everything and anything can and does happen. So we're going to add to our toolbox a little bit today and maybe build on our understanding. Well, when we're actually connecting to a device, it seems kind of silly to say, but you need wires, right? So if I said to you, what's this? Now, if you just watch the coax video, you might be tricked by the color of this cable, but this is got RJ45s on the end of it. So how would we describe this? Well, we might say it's a patch cable. We might say it's an Ethernet cable, and both of those would be accurate, right? But if you were really going to be pedantic about this, you might say, why? This, if it's a straight through cable, would be terminated on one side with EIA 568B and 568B on the other end. That would make it straight through. That would make pins 1 through 8 go to 1 through 8 on the other side. You might also say that this is stranded copper 8-pin terminated with the UDP RJ45s. So there you go. That's how you would describe this one. And because of the way it's terminated, we would say that its most likely application is Ethernet. But what if I showed you this one? You might, if you were being clever, say, why, that's a red cable. And that would be true. And the difference between this one and this one is not just the color, but the fact that one side is terminated EIA 568B and the other side is 568A. And what that means is that we are crossing pins 1, 2, 3, and 6. 1 to 3, 2 to 6, and so on. And that makes this a crossover cable, and we use this in particular locations in our network. Although, of course, today, many devices auto-sense what you're plugging into the Ethernet port, and so they figure that out for you. But what if I showed you a light blue cable? And in fact, a light blue cable that had a DB9 on one side and an RJ45 on the other. Well, this is a Cisco supplied console cable. Well, what does that really mean? Well, it goes to a different port on the router. It goes to the COM port, the serial port. So a COM port is a serial port, and the standard that's running there is EIA 232. So here I've got a yellow arrow pointing to what we call the console port, and the label is even light blue because it expects you to use one of these. Now you don't have to, right? You could build your own terminal cable, and what you would find out is that inside this, instead of being straight through or crossover, this would actually be a rollover where all of the pins are actually flopped. Now you can see also that I've got a USB to DB9 connector on here, and that's because most machines today don't come with a serial port. And so this is just a USB to DB9 adapter so that I can get to the right pins on the COM port or the EIA 232 port. Okay, so this is what I would actually do in real life. I would bring my laptop over or a desktop, bring the router over, and connect to the console, power up the router, and that's how I would actually start configuring the router. And that's what we're going to try and show you in Packet Tracer today. So I wanted to describe that because even in our labs, it's not always clear what's going on because we connect ready-made patch connections to our routers, and it's not always clear where the COM ports actually are. Now we also need software, a terminal emulator, to help us talk to the router over a serial connection instead of a data connection, which might run over Ethernet. And for that, we often use PuTTY. And so that's my favorite terminal emulator program. It does a lot of other things, but today we're going to talk about terminal emulation, even though the terminal emulator in Packet Tracer is not PuTTY, but it behaves in similar fashion. And then today we'll also add on the traffic generator and how we might actually configure the nodes with one-stop shopping. Okay, so there we go. That's what we're going to do today. So here we are in Packet Tracer, and you can see that I've got a topology. It's not actually built yet. I just have it wired. You can see that I've got a bunch of red arrows there indicating that they're down. And then I've got this mysterious node here off to the side. So let's talk what you might actually do normally when you connect to Packet Tracer. You might say, well, I'm just going to click on the router icon, and I could scroll down and find the ports that I want, right? Or see the modules that I could plug in here. And I might go to the config, and I can see that I've got fast Ethernet 0 and fast Ethernet 0, 1, or 0, 0 and 0, 1. And I could just click this little button over here and turn them on. I don't want to do that because I want to show you how you would actually do it in real life. In tons of examples, I've shown you how to connect via the CLI, and this is what you get, and this is the emulation that you would actually receive if you were actually connecting to a real router. But let's go a little farther than that. If we take a look at our cabling down here, right? This is the one that we almost always use, the straight through cable. There's our crossover. Well, what's this light blue one? Hint, hint, wink, wink, right? So what I'm going to do is I'm going to click on this light blue one. Let me get out of that for a second. You see over this? If I mouse over it, you can see that it says console underneath it. So here's what we're going to do. We're going to come up here. We're going to connect not to the Ethernet port, but to the RS-232, or now the EIA-232. EIA is Electronic Industries Association, and I'm going to connect this down here. But where do I connect it to? Right? Or to where do I connect it? Well, I'm going to go to the console connection, and what that does is that gives me my serial port based connection to my router. It's not an Ethernet connection. Now that I've done this, what I can also do is take this end of it and actually run it over here to this node too. Now you can see I've got two connections to this particular node. And this particular node is using an Ethernet connection to the switch, but it's using a different port to connect to the router. So you can see that I've got an Ethernet connection here, fast Ethernet 00, and fast Ethernet 01, but this is that serial connection. So what I'm going to do now is see if I can connect to the router configuration. Now what I'm going to use now, so this is the one that we always use. And now I'm going to use the terminal. Now, it is an EIA 232. So what it's asking for is the baud rate, right? How many bits per second do you want? The data bits, parity, stop, and flow control. So we commonly call this 96, 8, and 1. So that's 8 and 1, just like this, with no flow control. That's X on, X off. So we're not going to, whoops, we're not going to do any of that. So I'm just going to say OK here. And we can see that I have what appears to be a terminal. So I'm going to say no to the initial configuration dialog. Oh, I guess it already knew that. Okay. And if you compare this interface right here, right, to this interface, it's the exact same interface. This one's just built in. This is not what you would do in real life. So I'm going to do all my router configuration from the terminal here as if I was sitting at a PC connected to the COM port. So what I want to do is go to the interfaces. So now you can see that I've indicated I want to do 192.168.1.0 here. So that means this IP address is going to be attached to F0/1. So what I'm going to do is say I'm going to go to int F0/0, and I'm going to say IP address 192.168.1.254, and then I'll provide the mask, right, just like that. And then I'll say no shut. Now take a look here, right? It's bringing this interface up. Now I'm not actually going to have to do too much with this router beyond the other interface connection because it's just a two network topology. So now I'm going to go to F0/1 and I'm going to say IP address 192.168.2.254 and again the mask, and I'm going to say no shut. And if we look, we can see that that side is coming up as well. Now the reason these are coming up is because I connected them to switches, and the switches are alive like right away in Packet Tracer. And that's the way it would be if you plugged in a normal switch, right? It comes up and the ports all want to be forwarding or on right away. Now the delay time that we're experiencing here is very, very specific. It is the spanning tree delay. While the spanning tree does its topology discovery, and it'll take almost exactly 30 seconds every time. Now, the minute I do that, I now have two interfaces that are up, and I can exit out of what I was doing, and I can say a show, I can do a show run, right? So this is exactly what you would do in a normal connection setting, or if you were working on the CLI from the icon, but you can also do a show IP route here. And here I can see that I've got my 1net and the 2net, but then I also have the /32s that are assigned to the interface. Okay, well that pretty much does it for my router configuration, and I don't really need this terminal here, or this connection, this serial connection here, the COM port or the console. So I'm going to go back over to my PC, and instead of using the normal way that we would do this, right? So the common way that we do this is we go, well, I'm going to go to the config and we say we're going to go to F0/0 and I'll give it an IP address, and then I'll go to the global settings and I'll do the default gateway. But maybe there's another way. Maybe there's another way to take a look at this. And if I say I just want to do my IP configuration for Fast Ethernet 0, which is this one right here, I might say, well, I could do the whole thing right here. 192.168, whoops, 1.1, and then who would be my default gateway be? Well, it would be 192.168.1.254. And there we go. That's the whole shoot and match for this particular host. Now, if I get out of this and I say, well, let me go to the run prompt, let's see if I can ping my default gateway. There we go. So that is just a real handy way to do one-stop shopping instead of clicking through a couple of screens. So we'll do the same thing way over here. All right, we'll go to the desktop. We'll do our IP configuration. This one is on the other network, so it'll be 2.1, and its gateway will be 2.254. And just to make sure, we'll ping our gateway, and that works. Now, let's not forget, and let me move this over here for a sec, that we have a simulation tool that will show us when we want to ping all the way across the way. So here's the one that we use all the time, right? The command prompt. I'm going to go for broke. I'm going to try and ping across to the other side. So 192.168, 1.1. Now I'm simulating right now. So it's waiting for me to run this. So I'm going to go ahead and step through this. And we can see the packets actually fly. Now, if you've looked at the other examples on the channel here, you've seen this before, but if you've never seen this, it's pure magic, isn't it? You can see your packets go all the way across. There we go. Look at that. All right, so we don't want to forget about our simulation tool. We click to real time, and we have it back to normal where it just behaves as, you know, the speedy thing that it is. You can also get to these from the views here. Now, the other thing that I'll mention is, so that's the command prompt, the terminal, IP configuration. Let's also do the traffic generator today. That's this right here. Now, I can generate all kinds of traffic based on my settings or configurations that I do here. Now, this is a fantastic tool for testing your ACLs if you've ever built them, but I'll just show you real quick how it sort of works, because it'll build a header based on what you put here and not what might be your configuration here. It doesn't have to be exactly the same. Now, this one is ping, so that's pretty obvious. So if I ping maybe the other side, 2.1, and let's pick a different source address. Let's pick 192.168.1.99, right? And so I'm just going to send this, and I can do a periodic here, and maybe I'll do this every second or so. Oops, I forgot the sequence number. There we go. Now, you can't see anything, so let's go to our simulation, and we're stepping through this. Now, if I double-click on these here, whoops, actually, it's a single click. Stop it. There we go. And I take a look at the headers, I can see that it's going to 2.1, but it came from 1.99. And that's because this is a packet generator. It's not just taking the default settings for this particular node. And we'll just step through this, right? And it just, I will let it play. So this, the answer coming back, maybe. There we go. Now, the delays that you see here are the built-in delays for processing at each step of the way. So router routing table, router ARP tables, source address table on the switch, host ARP tables, host routing table. And then off another one goes here, right? Now in real time, it happens much faster because the simulation tool is not up there. So I'm going to go back to real time. And of course, you can't see this, but if you were looking at, oh, I don't know, maybe your tables, things of that sort, you would see the results of things like, you know, the ARP-A command. You would see they were talking to folks, and you could see the impact of things. You could also, if you had your ACLs, you could see the strikes against your ACL command lines. Now, the traffic generator is also fun because you can generate a much wider range of things. If I wanted to pick a particular set of ports that I was using, you could absolutely do that. So if you set up ACLs that were UDP based or TCP based, you can fire traffic based on that, and you get to pick. The minute I do something like this, you'll see that the port numbers are now exposed to me as well. So there you go. So the traffic generator, I encourage you to play around with it. and see what you can do to generate the traffic that you need to test ACLs or connectivity in your packet tracer topologies. Well, there we have it, getting a little more out of packet tracer. Remember that we started off the discussion with talking about how you would actually connect to a router, right? If I gave you a brand new router out of the box and I said configure this, you couldn't connect to it to software, right? You would have to get out your serial connections, your console connections, and then open up a terminal emulator program so that you could talk to the router. Then you could do the initial configuration, and only then, after you gave it an IP address, could you telnet or SSH or browse to it and start the actual configuration across the network. So that's a little view into the real life stuff. And we also saw that we can actually create those connections inside Packet Tracer. Now you can always just click on the icon and use all of the tabs that are inside there, but hey, try it out, see if it works for you, and you'll be better off when you hit real routers. Well, I hope this helped. Like and subscribe if you experienced illumination, and I will see you in the next one. And between now and then, whether you're using the traffic generator or you're just generating traffic with the command line interface, may those packet tracer packets always reach their destinations.